Hello everyone. So today in this video we are going to explore some of the essential concepts in configuring networking such as cluster networking, service discovery, load balancing and network policy, and understanding these components in Kubernetes is a crucial for managing and securing your application efficiently on a Kubernetes cluster. So let's get started. First, let's dive into cluster networking first. In Kubernetes, networking is vital to allow pods to communicate both with each other and the outside world. When you create a GKE cluster, each pod is assigned with their own IP address, and this setup means that the pods can communicate across nodes without requiring network address translation or a NAT gateway. So, for example, if I have the following workload deployed on a Kubernetes cluster, and as you can see, we have three pods running right now. And if I go onto console, type kubectl get pods hyphen and the name of the namespace, you can see we have three pods currently running in the following namespace. So, and if I want to look for IP address of all the pods, then I can simply use this -o flag with a void, and as you can see, each and every single pod that is running have a unique IP assigned to it, and these IPs are just internal IP which are managed by the Kubernetes cluster to distribute the load from a service onto these particular pods IP. Next, we have service discovery. In Kubernetes, a service is a REST object, much like a pod, and the service allows the application to receive traffic through a fixed IP and a pod pair, making the pods easily discoverable within the cluster. For instance, if you have a front-end application and a back-end application, for a service will help the front end to find and communicate between the backend consistently, even if the pods are replaced or scaled. So I have just deployed a sample backend application, and my application is nothing but a simple fast API, and I have created one endpoint /add. So what this API do, it takes two query parameter like two numbers and then return their sum with the key sum and their actual addition. And I created a Docker image of this particular backend file, this particular backend code, and deployed it on a Kubernetes cluster. And this is my image name that I deployed and pushed on Docker Hub. So you can also use the same image to try it out. So this is my backend app, which is running with three pods, and all pods are in running state. And if I hit this endpoint and I type /docs after the service endpoint, I can see I have my REST API exposed here. Now I'm going to deploy my front-end application. So my front-end application is just a HTML page which is taking two numbers as an input and hitting our API at this endpoint. So this is our endpoint, that is our exposing service endpoint, which is exposed as a service, and this won't change even the pods for our application gets restarts, or even if we deploy a new backend code. This service endpoint will remain constant until or unless we destroy the service or try to recreate again. So I have already basically dockerized my code and pushed onto Docker Hub, and this is my image repository. So I'm going to deploy this onto my Kubernetes cluster. For that, first we are going to navigate into front end folder, and I'll type kubectl apply -f Kubernetes deployment, then my service. So my service file for the front-end application is selecting a deployment name front-end app, which is my deployment here, front-end app, and exposing its port 80 as a type of a load balancer. So if we go back to our workloads, we can see we have a new workload created named front-end app, and the service for this workload is still provisioning, but our pods are in running status as of now. So our application is ready. If we go to this endpoint, we can see our front-end application up and running. So if I simply pass two numbers here, I'm gonna get the sum from the backend service that we deployed earlier, because ultimately it's hitting our backend API that we have created. So to verify that, if we go to network and just type the numbers again, you can see it is making an API call here. And if we check the header, we can see the endpoint or the service endpoint that is exposing our backend application. So this is all about service discovery in Kubernetes cluster. Next we have load balancing. So moving on to load balancing is critical for distributing incoming network traffic across multiple backend pods to ensure the application scales properly and remain highly available. And in GKE we can basically set up both internal and external load balancers. So basically the external load balancers distribute traffic coming from outside the cluster, while internal load balancer distributes traffic within the cluster. So the example of internal load balancer is something like service and the pods. So there are multiple pods having different IP, and our exposed service is load balancing that traffic into different pods. And the external load balancer distributes traffic coming from the outside the cluster, that is from a DNS server or somewhere, and it distributes the traffic onto that services, which further distribute traffic among the pods. So to simply deploy our external load balancer, we just create a service kind of Kubernetes manifest with a kind service and give it a name and a selector, the deployment that we are targeting, and expose it with the port number, and the type here is the load balancer. So it's going to distribute all the traffic onto the healthy pods only. As we wrap up, I hope this video helped clarifying how GKE handles networking from basic cluster configuration to more complex setup like load balancers and network policies. And thanks for watching, and if you have any question or need any clarification, feel free to drop a message on Slack.